So for number one, first step we're going to do is identify the null and alternative hypothesis. The null hypothesis is u equal to 210, and then the alternative is u is greater than 210. That's the first step. The second step is we're going to identify the significance level, which is 0.05, and then we're going to locate its critical value on the z-chart, which is 1.64. After that, we are going to use this formula and then we're just going to plug in the following numbers to it. And we will get 1.831. Alrighty, and our next step there, since 1.831 is greater than 1.64, we can go ahead and reject our null hypothesis because 1.831 is greater than 1.164. And then 5, it's rejected, and there is sufficient evidence to claim that the population mean is greater than 210 at a 0.05 significance level. Alright, now for number 2 here, first thing we have to do here is find the point estimate, and how you do that is you subtract both sample means. So 214.71 minus 193.20, and we will get 21.51. And now after that, we're going to go ahead and use to find the standard error of sample mean. So we're going to go ahead, hold on, I lost my, we're going to go ahead and use this formula here, which is so then we just plug those numbers into there, which equal this over 133, which is n, plus 33.04, and then over 41. If you're confused where we're getting these numbers, it'd be right here, which is, you can use this symbol to guide you with this symbol right there. Alrighty, and then that answer we would get 5.765. And then the central limit theorem is used for larger samples. So in this sample we're using here both 133 and 41, and then the sample mean is also large. So the central limit theorem is used for anything above 30. So yes, we can use this because both samples are greater than 30. All right, and for this fourth part here, first thing we're going to do is find the confidence interval for 90%, which turns out to equal 1.645. And now what we're going to do now is we're going to use the point estimate, which is up here, 21.51, and then we're going to do plus or minus the confidence interval times the standard of error, which will then get this, we'll simplify it down a little bit, plus or minus 9.483. 3. Now 21.51 plus 9.483 equals 30.993, and 21.51 minus 9.483 equals 12.027. So that will be our answer of 12, our little interval range, to 30.993. And we interpret this by, this means that 90% confidence that the true population falls within this interval. Alright. Moving on to question number 3, which gets a bit more complicated. First thing we do here is describe the relationship between political affiliation and opinion on tax reform. So the null hypothesis is going to be that there's independence between political affiliation and opinion on tax reform. And the other one is that there's dependency between political affiliation and opinion on tax reform. So using that, we are going to go down here. We have to calculate the chi-square statistic. So first thing we're going to do is we're going to use this formula right here. X squared equals alright, and then we're going to make a table with the categories O, E, O minus E, O minus E squared, and then O minus E squared divided by E. And now I already made one of these tables, which will be listed in the other document attached. So basically at the end, we're going to get the sum of this, which turns out to be 22.15. So then after we have that, we're going to go look at the level of significance, which is 0.01, and then using this chi-square table, we're going to get a critical value that is equal to 9.210. And now we can conclude that since the test statistic is greater than this critical value, we can reject the null hypothesis. And then this means that the results are being, there's dependency present in the results. All right, moving on to question number 4. Alrighty. First thing we're gonna do is calculate the sample correlation coefficient for R. And how we are gonna do that is first we must make a table with the top labeled X, Y, X minus squared, and then X, or Y minus Y squared, and then we're gonna make X minus X, and then Y. Alright, and there's also another table that I made that you can see on the other document that's attached. But after we get that, we're gonna go down and use this formula. And this formula is over square root alrighty, and then we're just gonna plug in some of the numbers that we get from this table that we made in the other document. we get 0.879. And this means that there is a positive correlation between X and Y. Now this S here, this is the sum of the XY category, which would be this category here coming down. And then the XX would be this one, the sum of that one, and then the sum of that one. So that's where you'd get those numbers after you have the completed chart. Alrighty, for number 2, we're gonna use, first thing we're gonna do is look at the hypothesis. So this one equals P equals 0, and then each one equals P is greater than 0. Alright, so then to find the T, we're gonna use this formula here. And then after we plug this in like so, which is 0.879, and this R right here is just this number that we got up here. And we're gonna times that by the square root of 13, and then 1 minus 0.879 squared, and turns out we get this answer right here. Now then we're going to locate the critical value, which would be this. We're using the critical values table with the with all the numbers that we need, and then we know that 6.647 is greater than 0.441. We again reject null hypothesis, because this is greater, so this would be confirmed and this would not. Alright, and for the last and final part, we're going to use this formula, y equals a plus bx, and then we already know that x equals 18, so that we're just, and then b is going to equal r times, and then once we figure out b, which b will be equal to 182.087, we can just plug them in like we're used to doing, which is, so we get negative 4010.5659 plus 182.087 times 18, which that answer equals 732. Alrighty, and my name is Robert Bishop, and my UCID is M1230114. My name is Robert Bishop, and that is my M number. Alrighty, thank you.